Okay, welcome back to math class and welcome to part 2 of our lesson on tangents. We learned yesterday what a tangent was. That's a line that intersects a circle at one point, right? That's a tangent, that's what we learned. Today we're going to take it one step further. Instead of just one tangent, what happens if there are two tangents? So, if we have two tangents and they come from the same exterior point and then they both intersect our circle, because they're tangents, so they intersect our circle at one point, but they originated from the same point, then that means the segment formed from this point to where it intersects the circle are going to be congruent. So if these were A, B, C, AC equals AB. They're congruent line segments. So if I told you that AB equals 3x plus 8 and AC equals 26 and said solve for x, what you're going to do, you know these are congruent, so you're going to set 3x plus 8 equal to 26 and then solve. Minus 8, so we get 3x equals 18, x equals 6. Pretty simple. I think you guys can do that pretty well. What else we can do with this information is figure out what to do when we have circumscribed polygons. Polygons that are on the outside of our circle. So for example, here we just had 2, but if I extended these out a little bit so that we had one more tangent, now we have, I know it's not very pretty. We have a circumscribed triangle. A triangle that's on the outside of the circle, and each side of the triangle must be a tangent of the circle. That's critical for circumscribed polygons. It's a shape on the outside of a circle, and every side of that shape must be a tangent of the circle itself. What we can do with this information, though, what we learned about angles here, or what we learned about tangents that come from the same point, is now I can say, I know these two are congruent, I know these two are congruent, and I know these two are congruent. So I'm going to give you an example of one of the problems that are going to be on your homework. Suppose instead of that, we have, I tell you that, let's see, we have A, B, C, D, E, F. Okay, so suppose I told you that A to B here is 8. And then I told you D to C here is 7. And then I told you D all the way to F was 10. This whole side was 10. And then I said to you, find the perimeter of this triangle. Now finding the perimeter, if you guys remember, means finding the distance all the way around the triangle. So basically I need to be able to figure out what each one of these sides equals and then add them all up. Each one of these segments. So I know that this one and this one are congruent. So if this one is 8, that one's got to be 8. I also know that this one and this one are congruent. So if this one's 7, this one has to be 7 as well. What I need to figure out now is FB. Now what I know is that the whole side is 10, this portion is 7, so this portion is going to end up being 3. 10 minus 7, 3. And I know that these two are congruent, so that one has to also be 3. Now to find the perimeter, I just add up each of the sides. So I'm going to go 3 plus 8 plus 8 plus 7 plus 7 plus 3. When we add that all the way up, that's going to give me 36 as the perimeter of this triangle. Now we figured that out because we know that when two tangents come from the same point, they're going to be congruent. This works no matter how many sides it has. If I used a quadrilateral, for example, I would still be using this principle. I would just have 4 instead of 3. So you should be able to figure all of this out on your own. I think you're going to do a great job personally.